Let's continue discussing more properties of these trigonometric functions. So all I have written here are the definitions of all the trigonometric functions we know so far. So cosine of t is the x-coordinate of the terminal point, sine of t is the y-coordinate, and etc. So there are various ways to relate these trigonometric functions to one another. For instance, let's take a look right here. Cosine of t is x. And well, secant of t, that's 1 over x. So if I know x is cosine of t, then that must mean that secant of t is 1 divided by x, but x is cosine of t, so secant t is 1 over cosine t. This is one of what's called the fundamental identities. The fact that secant of t is 1 over cosine of t. There are some more. If we take a look at sine of t and cosecant of t, we get something very similar. Cosecant of t, that's the same thing as 1 over y, and y is sine of t. So this is 1 over sine t. What about tangent of t? Let's take a look at that. So tangent of t, that's y over x, and y is sine t, and x is cosine t. So I replace the y with sine t and x with cosine t, and I get another fundamental identity. And finally, cotan, not cosine, but cotan of t, that's x over y, which is y over x, that's just flipped. So that is the same thing as 1 over tangent of t, which if you replace x with cosine of t and y with sine of t, you get that this is cosine of t divided by sine of t. And these here are the so-called fundamental identities. In other texts, they're also sometimes called the reciprocal identities. So reciprocal identities. And by their name, the fundamental identities, you can probably guess that they're pretty important. They're also not too challenging to remember. If you remember the definitions of the sine and cosine and secant, cosecant, tangent, and cotan functions, then you can kind of see that one, such as the secant t function, is 1 over the cosine t function. Now, another identity that is perhaps equally as important, maybe even more so, is modifications of the Pythagorean identity. So remember, the Pythagorean identity says that sine squared of t, usually we put cosine squared t, so let's put that first. So cosine squared t plus sine squared t is equal to 1. And now, remember, this is true for all t. Doesn't matter what t is, cosine squared t plus sine squared t is 1. And now you can take this identity and we can multiply or divide both sides by whatever we want, and we would get a new identity. In particular, if you divide both sides by sine squared t, then we get an identity that is very useful. So we have cosine squared t over sine squared t, plus then we have sine squared t divided by sine squared t, and that's just going to be 1, and then we have 1 divided by sine squared t. Do remember that when we write cosine squared t or something of that nature, that's the same as cosine of t all squared. Also remember, 1 over sine t, that's cosecant of t. And so this right-hand side is going to be cosecant squared of t. Sine squared t over sine squared t is 1, so plus 1. And remember cosine of t over sine of t, that's the same thing as cotan of t. And so cosine squared t over sine squared t is going to be cotan squared of t. And so this is another form of the Pythagorean identity. Another form can be attained if instead of at the very first step, when you divide by sine squared, if you divide by cosine squared t. If you divide both sides by cosine squared t, then what you get is 1 plus tangent squared t is equal to secant squared t. I'll let you run through the details if you'd like, or consult the textbook for the details if you'd like to see them. And for completeness, I'm going to put the original Pythagorean identity here, cosine squared t plus sine squared t equals 1. These three are all called the Pythagorean identity. So I suppose I would call all three of them the Pythagorean identities. Let's take a look at an example which uses both the Pythagorean identities and also those fundamental identities. So let's suppose that we know that tangent of t is 3/5. And we also know that 0 is less than or equal to t is less than or equal to pi over 2. So in other words, t lies in the first quadrant. So you could replace this information here with t is in quadrant 1. Let's find sine of t and cosine of t. Now in this type of problem, I know tangent of t, and what I would try to do if I know one piece of information of some trigonometric function, I try to relate it to using some sort of identities to other trigonometric functions. So one thing that you might think to do is tangent of t is the same as sine t over cosine of t. However, when you write it in this way, we don't know what this or this is. We don't know what sine of t is, we don't know what cosine of t is. And in general, if you have one equation and two things you don't know, you can't solve that equation. You know what tangent of t is, but there's two things you don't know in this equation that I've written. And so that, without some modification, is not going to lead you in the direction that you want to go for this type of problem. However, if you take a look at one of our new Pythagorean identities, that relates tangent to secant. And secant is the only thing that's unknown in this Pythagorean identity. So what I'm going to do is I'm going to figure out what secant is, what secant of t is, and then I'll use my fundamental identity that secant of t is 1 over cosine t to figure out what cosine of t is. So let's see how that goes. So 1 plus tangent of t, tan squared of t, is equal to secant squared of t. And now tangent of t is 3/5, so tangent squared is going to be 9/25. So 1 plus 9/25 is equal to secant squared t. And you can combine 1 plus 9/25 by getting a common denominator. 25 plus 9 is 34, so that means that secant squared t is 34 over 25. And so that means that secant of t is plus or minus the square root of 34 over 25. Plus or minus because remember, if you solve something squared equals a numbers, like x squared equals 9, then the solutions are plus or minus the square root of 9. So that's why we have this plus or minus here, because we have a square. And now if you take the square root of a fraction, that's the square root of the numerator, so 34, divided by the square root of the denominator, and 25 is the denominator. Square root of 25 is just 5. So secant t is plus or minus root 34 over 5, but it's not both plus and minus because there's some additional information here. It says that t is in quadrant 1. So if you think about, or I guess the original information is that t is between 0 and pi over 2, which means t is in quadrant 1. So if you think about your unit circle in quadrant 1, that doesn't look much like a circle, but perhaps you can imagine. The x and y coordinate on the unit circle on the terminal point are both positive, and secant of t is 1 over x. So if x is positive, then that means that secant of t is going to have to be positive. And this is a very typical problem, or perhaps better said, a typical characteristic of these types of problems. You'll get that some trigonometric function is equal to plus or minus something. And you'll have to determine if it's plus or minus based on the quadrant that t is in. So if we said that t was in quadrant 3, then the picture would look instead something like what I've just recently drawn, and the x and y coordinates would be negative. So in that case, you would have picked the negative here because the x coordinate is negative, so 1 over x is negative. But that's not what the problem says, so we'll continue with what the problem says. So now we know what secant of t is. We have secant of t is the positive square root. So let's write it out. Secant of t is equal to the square root of 34 over 5. And that allows you to determine what cosine of t is, because remember, secant of t is equal to 1 over cosine t. So 1 over cosine t is root 34 over 5. I can multiply both sides by cosine of t and divide by what is over here on the left-hand side, and I would get that cosine of t is equal to 5 over the square root of 34. All right, so now we know half of what we were asked for. We know cosine of t. Keep in mind we also know what tangent of t is. Tangent of t is 3/5. And now we have to figure out what sine of t is. And there's a number of different ways that you can proceed. I'll give you a couple. The first thing you could do is you could say, well, you could use one of the fundamental identities. Tangent of t is sine t over cosine of t. And now earlier, we didn't know either sine t or cosine t. But at this point, we know cosine of t, we don't know sine of t, and we know tangent of t is 3/5. And this will allow you to solve for sine of t. So multiplying both sides by cosine t, we get sine t is 3/5 times what cosine of t is. Cosine of t is 5 over the square root of 34. And so the 5's cancel and you get 3 over the square root of 34. By the way, it would probably be most appropriate to give your final answer with a rationalized denominator, that is, multiply the numerator and denominator by root 34 over root 34. And if you did that, the cosine t answer would be 5 root 34 over 34. And the sine t answer would be 3 root 34 over root 34. Excuse me, not root 34, but 3 root 34 divided by just 34 without the square root. So this is one way to figure out what sine of t is. It's probably the easiest way, but there are other ways. You're not required to know these other ways, but you should know that the more practice with these types of examples you get, the easier things will get. So another way that you could figure out what sine of t is you could use the other Pythagorean identity, that cotan squared of t plus 1 is cosecant squared of t. And now, it wasn't given to you what cotan of t is, but cotan of t is the same thing as 1 over tan t, and tan t is 3/5, so this is going to be 5/3. Then you can figure out what cosecant is the same way that we figured out what secant was over here, and that will lead you to what sine of t is. So we'll replace cotan of t with what it is, 5/3. So this is 5/3 squared plus 1 equals cosecant squared t. Then we can combine the left-hand side. That's 25/9 plus 1. And we'll get a common denominator, 9/9. So that is 34/9. And that has to be cosecant squared, CSC squared t. And if cosecant squared of t is 34/9, then that means that cosecant t is plus or minus the square root of 34/9, which is plus or minus the square root of 34, and the square root of 9 is 3, where again we'll take the positive because again we are in quadrant 1, and in quadrant 1 the y-coordinate, and we're looking at the y-coordinate because cosecant of t is 1/y. The y-coordinate is positive, which means that, well, 1 divided by a positive number is positive, and so cosecant of t has to be positive. And so we get the square root of 34/3, that's cosecant of t. And remember, cosecant of t, that's 1/sine of t. So cosecant t, that's 1/sine t, and that is the square root of 34/3. And that means that sine of t would then be 3 divided by the square root of 34. And so this is another way to get the same answer here for sine of t. Of course, I think that the other way is a little bit more direct here, but the second way is just as correct.